Hello, friends, and welcome to Pathologic Volume 4, Episode 19. Today we've got a puzzle with some arithmetic in it, but don't worry, the numbers are pretty small, so I think it's still pretty approachable. This is called a tom-tom, and let's just dive right in and take a look at the rules. Tom-tom is a Latin square puzzle. The rules are: place a number from 1 to n into each cell so that each row and column contains every number from that range with no repeats, where n is the side length of the grid. It's a very precise and wordy way of describing the normal Latin square constraint. We just have no repeats in rows and columns, just like a Sudoku, except for the region constraint not being there. A clue represents the value obtained by applying an operation iteratively on the numbers in the region the clue is in. So, this is difficult to describe, but you can see it in the example. This 6 plus is saying this region, the digits in this region sum to 6, and the digits in this region have a product of 12. If no operation is given, it may be any of addition, subtraction, multiplication, or division. Subtraction and division in regions with more than two numbers are handled by taking the largest number and subtracting or dividing all the others. So, in the example of this 2 division clue, we start with the 4, we divide by 1, we divide by 2, we end up with 2, which is what the clue is looking for. In the example of the subtraction, we're starting with the 4 and subtracting 2 and then 1 to get 1. Those are the rules of tom-tom, so it's time to solve a puzzle. Today's tom-tom puzzle was set by Freddie Hand. I am looking at a grid that is 5 by 5, so that is the range of digits that we have to work with, 1 through 5. And I see we've got our usual rule of looking for big and little numbers. The little numbers don't look that useful because there's lots of ways you could arrive at some of these numbers. But I see the big ones look more fruitful. These 10 times clues are going to be 2 and 5 in some sequence. That's the only way we can multiply to 10 when we're constrained with numbers from 1 to 5. So those are both 2 and 5. This 10 plus, how can that be? If we didn't have a 5 on it, then it would have to be a 432 is the most we could do in 3 digits, which is only 9. So it does have a 5 on it, and then the rest of it is either 4, 1, or 2, 3. But the interesting thing there is that it does have a 5, which knocks the 5 out of here and places a 5 here. That knocks the 5 out of here, places a 5 here. And because there's a 5 here, this one is not a 5. So we are off. This 2 minus, how are we going to do that in 3 digits? We've got to start with something and subtract 2 different digits from it to get 2. The smallest those additional digits would be 1 and 2. Subtracting 1 and 2 from something and getting 2 is, if we work backwards from the 2, it's like adding 1 and 2 to the 2, which gives us 5. So this is a region with 5, 1, and 2 in it. And the 5 and the 2 are not in this cell. So this one is the 1. And these are a 2, 5 pair. And that's going to be what that region looks like. In this row, all that leaves us with is 3 and 4. The same is true in this column, 3 and 4. But this 3, 4 is in a region, a 2-cell region that says it divides to get 2. How would 3 work there? 3 would have to go with a 6 to make that true, and we aren't allowed 6s in this puzzle. So this is not a 3. This is a 4. This is a 3. And 4 must be divided by 2 to get 2, because we can't go up to the 8. So that's a 2. In this column, we're left with a 1 and a 4. So I'll mark that. All right. Now we probably have to think about this 10 plus. What's left in this column? 1, 3, 5. Are any of those... I mean, we said this is a 5 with either a 2, 3 or a 1, 4. But actually now we know, because of this 2 here, that this is not a 2, 3, 5. This is a 1, 4, 5. So this 3 is out. Oops, just this one. 1, 4, 5 is what the composition of this is. 1 plus 4 plus 5 is 10. Yes. So that leaves us with a 3 in this row. Good. 5 is knocked out of this one. 5 is knocked out of this one. So neither of those are 5. This one is the 5. And what's left is a 1, 4. Like so. We are down to this clue, really, is what is going to have to do the rest of the work. I'm just kind of scanning to see if I've missed any other obvious cancellations. No, I think we have to think about this two difference. So the difference of the 2 digits in here is 2. What are the possibilities? It could be 1 and 3, but it's not 3. Could be 2 and 4. Could be 3 and 5, but again, it's not 3. So this is 2 and 4. And so now that's going to give us a 5 and a 2 up here. The 2 is going to come over here and knock this 2 out. So it's 4, 2. 4 gives us 3, 4. The 4 gives us a 1 and a 4 and a 1. And this last clue, last digit in this row is the 5. The last digit in this column is the 1. And the 1 is going to disambiguate this 1, 3 pair. And then here we've got a 3 and we've got a 4. And that is how you solve a tom-tom.